as compared to non-parametric test. So if you are fulfilling the assumption, it's always better to apply parametric test. But if you are not able to get normal distribution, if you are not able to fulfill all the assumptions of the parametric test, then better to go for non-parametric tests. Okay, so you have all parallel to parametric, you have other non-parametric tests that you can always apply. So here in case of ANOVA, you can apply Kruskal-Wallis. While yesterday we discussed in case of t-test, independent sample t-test, we applied Manvetti U-test. So all these tests are there that you can apply. 21 participants are there, 20, which means 18 are there. So I think I should start ANOVA, and then I'll discuss the another topic, which is correlation and regression. Okay, so ANOVA, I'll start with that only, that data set only that we were doing yesterday. I request all of you to use SPSS on your laptop, plus please have that file that was shared with you. And so open it on your SPS. I think most of you have already having that file. So I'm showing you that only. My screen is visible. This is the data set that we have. Okay, so this you have with you. Hello, am I audible?
Yes, ma'am, we have it.
Okay. So we'll go to analyze, then compare means and proportions, then one-way ANOVA. And this is what we, this amount spent on food items. This we took amount spent on food item as dependent list, and we wanted to see whether there is any difference in terms of like a family size, number of members in a family. There is any difference with respect to amount spent on food items. Okay, so we applied post-hoc also. In post-hoc, you can choose this Tucky, post-hoc Tucky test. Okay, use the same significance level alpha and then continue. And then, okay. So here you can see the test of homogeneity of variance, Levin statistic. This should not be significant. Okay, because what is our assumption? That the variance in different groups, there is a homogeneity in variance, which means all the groups that we have, it should show same variance. The 4 groups that we were having in this particular category was, I think, 1 member in a family, 2 members in a family, members in a family, or 4 members in a family. So it should show same variance. Both the all the 4 groups show same variance, which is not there because this significance value should be more than 0.05, which is not there in this case. So this assumption was not met, although your ANOVA value is significant. And that is the reason I applied post-hoc test also yesterday. But post-hoc Turkey, we are not getting any significant value here. So if there is a difference in mean of 4 groups, that is what is given here in ANOVA, that ki 4 groups that we selected, ki whether there is any difference in terms of amount spent on food items. So this shows ki yes, there is a difference, but where is difference? That is given by post-hoc test, post-hoc Turkey test, but post-hoc Turkey test is not showing significant value in any of the case. Okay, so instead of this, because if you are not fulfilling the assumptions, then you should not apply parametric test. The first thing is because we are not fulfilling this assumption, so we should not apply ANOVA. So instead of ANOVA, what we can do? So you'll go back to your SPSS data again, and or what you can do, you can also like this is if you are interested in this only, then we'll look for non-parametric tests. Okay, so non-parametric test may you'll go for legacy dialogues, and you have this K independent samples. So you will this is a non-parametric test that you can use in place of ANOVA. So there we have chosen amount spent on food item. So I'll choose the same question here, same item here, amount spent on food item. And family size, I think we have chosen. So family size is 1 to 4. Or if it is not here, then you can define range, minimum is 1 and maximum is 4, and then continue. Okay, and you need to take here Kruskal, Wallace, H. And then, okay. So here you can see this is 869 was my sample size. So total is amount spent on food items, all 869. Mean was this. Family size may 869 as my total people, but family size may there are one member in a family, 2, 3, and 4. So 3.5 is the mean, which means 3 and 4 in between. The most of the people in my sample are either having 3 members in their family or 4 members in their family. This is standard deviation and minimum and maximum. Then ranks may you can see amount spent on food item. 1 member family, 18. 2 members family, 58. 3 members family, there were 250 people, and 4 members family, there were 543. Mean rank is 461, 452, 465, and 418. It takes rank. And here you can see the results are not significant here also. Okay, so you cannot say that there is a difference. Okay, so results are not significant here also because the value is more than 0.05. So you cannot, like you're not able to reject your null hypothesis. Is this clear? Is this clear? Yes? Okay.
Yes, ma'am.
Okay, so let's apply ANOVA where we might get a significant result. So I'm using some other maybe items from my questionnaire. So if I take current visit time taking to reach mall or number of store visited, for example, if I want to know whether there is any difference with respect to family size and a number of store visited, is there any difference? Or like whether you are 1-member family, 2-member family, 3-member family, or 4-member family, you visit in a month same number of stores. I want to see whether there is any difference. If your family size is big, you go to store more often, or if your family size is small, then you go to store more often. That is my hypothesis, and I want to check it. So first thing is I'll again apply ANOVA. So post hoc, Duncan is also considered to be one of the tests which is good for checking variance. Post hoc I've applied, and then okay. So here again I am not getting this test of homogeneity of variance significant. So although my this value is significant, ANOVA is coming to be significant, and let's check this, and this is also coming to be significant. Multiple comparison में post hoc is also coming to be significant, which means कि 1-member and 2-member, 1-member and 3-member, 1-member and 4-member, there is a difference. So people who are if when there is a if you talk about the increase in family size, there is a difference in number of visits to stores. So where is the difference? 2-member and 1-member, there is no difference. 2-member, like here you will see 2-member and 3 and 2 and 4, there is no difference, but 2 and 1, there is a difference because that result is significant. But since my Levin's test is not coming out to be like homogeneity of variance is not met, so again I will not use ANOVA. I may go for other tests like Kruskal-Wallis. So similarly, you can check with other also, and you can see whether your result is significant or not. Okay, like for example, I just want I should get one significant value. So let's have some other question here. For example, in terms of kids number, if I say, and amount spent on food item, if I take this, and let's again apply the same test. In all the cases, test of homogeneity of variance is not met. Although other places I am getting significant result, but since this is not met, so I am not using this. Okay, so instead of this, what you can do is you can go for Kruskal-Wallis. Kruskal-Wallis may, what you will do, you will go for to non-parametric, this legacy dialog. K independent sample is for if your results are not significant in ANOVA, then you can use this. Amount spent on food items and with respect to number of kids. Zero. Minimum was 0 and maximum was, I think, 3. Continue. So this is what I am getting. My result is significant here. So amount spent on food and number of kids. Most of the people here have, like this also I tested earlier also, 1.7 is the number that I'm getting, which means most of the people have they have 2 kids in a family. Then this is my mean rank, and there is a difference in terms of amount of spent on food item. Is this clear? Any doubt here? Because now I'll move to a different type of test, which is correlation and regression. Here, what we were doing was we were comparing the means. So, if your hypothesis is related to this, there is a difference in mean of two different groups, then you can always use t-test, different type of t-test and ANOVA, depending on the type of group that you have. Whether you have done like pre and post tests, so you can use paired sample t-test, or whether you have chosen number of groups more than 3, then you can use ANOVA. If you have just one sample, then one sample t-test. But these all tests that we have done yesterday and today, they are all comparing means. So if your hypothesis is related to this only, there is a difference in mean of two group, or there is a difference in like amount spent on food items with respect to family size that we were using. So you can always go for t-test or ANOVA. So t-test and ANOVA is actually what it is doing. It is actually looking the mean and comparing the means of different groups. But if your hypothesis is related to relationship, for example, is there a relationship between the two variables? Like if you want to know whether there is a relationship between price and of product and your income and expenditure, or income and saving, or like the price and demand. So these kind of things, there is a relationship between two variables. Okay, so if you want to see the relationship between two variables, then you are not going to apply t-test or ANOVA, because there it is only what it is doing, it is looking after the mean and it is comparing the mean of different groups or subgroups. But if you want to see the relationship between the variables, maybe two variables, or maybe with dependent and independent variable, with one dependent and many independent variable, so you will have regression. If you want to see the relationship between two variables, then you will use correlation. Okay. So now the hypothesis that you will be using, the test that I'm going to tell you, those tests will be applied in case of the hypothesis which talks about there is a significant relationship between price and demand. For example, this is your hypothesis. Okay, so that will be your null hypothesis. But your objective is to reject this, because you know that there is a relationship between price and demand. You always try to question null hypothesis. So if you have this hypothesis, there is a relationship between price and demand. There is a relationship between income and expenditure. There is a relationship between pollution in Delhi and health hazards, or your asthma, for example, pollution and asthma patients and pollution levels. So relationship, you want to test the relationship between two variables. So if there are two variables, correlation. If there are more than two, then regression. Regression where you have one dependent, one independent, one dependent, or multiple, many independent variables. Okay, so I'll start with correlation. So, but always keep in mind that your hypothesis now will be of different type.
Ma'am, can you please tell me that you are saying that if we are having more than two variables and we have to show a relationship, then we will use regression, right? And what about the dependent and independent variables? You just said, please say it again, ma'am.
Dependent, जैसे अब तुम्हारा है, like you have dependent, maybe any variable you can take as dependent variable, like your income is dependent on your qualification, okay, and your experience. So these are two independent variables, and dependent is your income. So salary will depend on your experience and your qualification. Okay, so two independent and one dependent, and you'll make a equation. In case of regression, I'll tell you the results that you'll get. Then on that basis, you'll make one equation, and that equation will tell you how much there will be change in dependent variable with respect to change in independent variable. For example, if you have 3 years of experience, then maybe 1 unit change in your salary. So this kind of relationship, or if you have, if your degree is from a very good institution, then you'll have more salary. So this kind of if questions you have in your questionnaire, and you want to see whether there is a relationship with salary and like experience and salary and with your qualification. So there are two variables, and not just one. So there are two variables. So you want to see the relationship, and there is dependent also and there is independent also. So you can always go for regression. Okay, there are like many of you from Jamia Hamdard itself, PLSM is something that we use for dependent and independent relationship, and many of you have written paper also on that. So that is something which is beyond this workshop, maybe like but that is also one of the things which will make a very beautiful model if you're having many dependent and independent variables. So you can use PLSM also for that. Okay, so but here I'll be discussing with you correlation and regression, and then maybe decision trees, one thing that I want to discuss with you. So I'll start with correlation. So correlation is basically relationship between two variables you want to see. You have correlation. The two variables, the variables of interest, need to be using a continuous scale. So first assumption of correlation is that both the variables should be on continuous scale, which means either on interval or ratio scales. Second is the two variables of interest should have a linear relationship, which you can check with the scatter plot. You can make a scatter plot and you will see the relationship between two variable, and the relationship should be linear. Linear is you can draw a straight line. It can go upward, it can go downward, but the relation should be linear. Third is there should be no spurious outliers, which means the data that you have collected should, when you are plotting a line, it should fall on that line. There should not be significant outliers, which means your data should not go here and there. It should follow a pattern, a line. And fourth is the variable should be normally or near to normally distributed. Like I told you yesterday also, you should have bell-shaped curve. Okay, so your data should be normally or near normally distributed. Then only you can apply correlation, because correlation is also a Pearson correlation that I'll be using right now is a parametric test, and for parametric test you need to fulfill all the assumptions. So when we talk about correlation, so the value that you will get in case of correlation, your value will range from +1 to -1. Okay, so +1 to -1 means that if there is a positive correlation, then your value will be in between, like 0 is the middlemost value, which means that there is no relationship between two variables. So if no relationship, then 0. If you have value 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 until 1, that means you have a positive relationship between two variables. And if this value will go from 0 to -1, that shows there is a negative relationship between two variables. So -0.1, -0.2, -0.3, -0.4 till -1. The relationship is negative, and from 0 to +1, the relationship is positive. Higher the value, more the relationship. So if you have like 0.4, 0.5, 0.6, 0.7, that is showing the relationship is good. More the value, more the relationship. If it is at negative side, that means there is an inverse relationship, which means if there will be fall in income, there will be lesser savings. So that is the positive relationship. But if there is a negative relationship, for example, price rise, fall in demand. Price badhega to demand will go down. So inverse relationship should be there between the two. So in that case, it should go towards negative side, which means the value should be from -0.1, -0.2 till -1. So negative If it is like more the value towards negative side, then more the inverse relationship. More the value towards positive side, that means more the direct relationship is between two variables. Now, this is your data that is with you. So what we'll do now, I'm going to apply correlation. So correlate, bivariate, and I am choosing all the scale because interval and ratio. Scale I need to choose so I can take more variables here. You can also choose variables from or items from this. These are the items from your questionnaire. So scale item you can take. Pearson correlation should be taken here. Two-tailed test. If you want, you can also click for mean and standard deviation. Continue. And okay. So this is the mean and standard deviation of your data. Then this is correlation value. So what you should see here. So significance level and Pearson correlation. Two things you should see. This is a sample size, which is common for all because 869 was our sample size. Second thing that you will be looking for is significance. Significance level should be less than 0.05. So this is significant, this is significant, and this is significant. So all places where you have asterisk mark, that is significant. What it signifies, like I told you, 0.106 amount spent on food item. I have not actually seen whether I am interested in these two things or not. I am just applying the correlation test. When you will be applying the correlation test, you need to see your hypothesis and whether you want to see the relationship between two, then only you will apply. I have just applied on random basis. So for example, this is amount spent on food item and a current visit time taken to reach mall. Time taken to reach mall and amount that I spent on food item. So there is a positive relationship between 2.106 because this is the positive relationship is there, but not very strong relationship, but yes, positive relationship is there. So, but I'm not interested in looking this because I need to see which hypothesis, like for example, strong relationship. Let me see if something is above 0.5. This is 0.422. So this is good relationship. This is I often crave excitement, and it has positive relationship with I follow the latest trends and fashion. So yes. So this is a personality type, and this is also ki I follow the latest trend and fashion. So this those who are like looking for something which excites them, they also follow the latest trends and fashion. So that is something is like I might be expecting from my study, and if I'm getting it, so this is showing a positive relationship, and the value is 0.422, which means there is a good relationship between these two. 0.585, 0.634, this is a good relationship. This was I like outrageous people and things, and it has a good relationship with this, which is I like a lot. What is it? I like a lot of varieties in my life. I like a lot of varieties in my life with I like outrageous people and things. So I randomly actually taken questions from my questionnaire. But when you will be applying a correlation test, you will be looking for your hypothesis. Ki whether I want to see a relationship between these two or not. And if the value is like 0.422, 0.5, 0.6, 0.7, then 0.8, it's a good relationship. In social sciences, we consider 0.4, 0.5, 0.6 also a 0.5, like above 0.5 and 0.6 as a good relationship between two variables. So if you are getting this, you can always put in your study that there was a positive relationship between the two variables. So this is how you apply correlation. So correlation is something where you are looking for the relationship between two variables. Both the variables should be on continuous scale. And first thing is we look for the significance value, and second thing is we look for the this Pearson correlation value. The value will be from -1 to +1. More the value, higher the relationship between two variables. But if you want to see the inverse relationship, like here, this minus value shows inverse relationship, which means amount spent on food item, like number of store visited, but this should be, I think it should be positive. So amount spent on food item is less. If you visit more stores, you will spend less on food. This is what it is showing. So this is a negative relationship. So you will see whether your hypothesis, in your hypothesis that you have framed for your study, whether you want a positive relationship or a negative relationship. And then you will see whether it is coming through my correlation value or not. If it is not coming, then in that case, definitely you will say that you have rejected the null hypothesis. Is this clear? Yes or no?
Yes, ma'am.
Yes,
Okay.
ma'am.
So that is about correlation. Next is your regression. Regression is you can have one dependent. I'll start with this, one dependent and one independent variable. So coming to regression, next is your regression. Here again, assumptions are your dependent variable should be measured at the continuous level, interval or ratio. Assumption number 2 is your independent variable should also be measured at continuous in case of linear regression. But in case of multiple, like you have variables, then in that case, it can be an ordinal or nominal scale also. Assumption number 3 is there need to be a linear relationship between the two variables. There should not be any significant outliers, like I told you. Fifth is you should have independence of observation. And for that, in regression, we also, when you will be applying a regression test, then you will be taking on Durbin-Watson statistics also. The value should be less than 2. And if your value is less than 2, then you can say that key observations were independent. So there need to be independence of observations. And sixth is your data needs to show homoscedasticity, which means line of best fit. Again, if homoscedasticity means if I'll draw a line on graph, then I should be able to draw a line, either it is moving downwards or upwards or a straight line, but I should be able to draw a straight line, either up or down or in between. My data should not be scattered here and there where it is not following any pattern and I'm not able to draw a line. So that should not be there in case of my data. So it should have some pattern. Then only I can go for regression, because regression tells you ki if there is an increase in one thing, how much increase in other thing will happen. Okay. So if there is an increase in independent variable, whether there will be increase or decrease in dependent variable or not. Like I have given you example, okay, if there will be more experience, so whether there will be more salary, if yes, then how much change in salary will be there. So it should have some pattern, then only this kind of relationship can be established. If there is no pattern where I am not able to, I have collected the data and it is not showing any pattern, So it is very difficult for me to apply regression, because regression assumes that it has a pattern. The data, either the line is going upward, straight line if I'll draw, I can draw a line upward or downward or a straight line, but the value should, like the data should not be scattered. Like it is not following any pattern. That should not be there. So homoscedasticity is one of the assumption, which is line of best fit. So all these assumptions, first I need to check. I'll see my questionnaire. I'll choose interval or ratio variables. I'll see whether I can apply, like I can choose independent variable which is on continuous scale or not. Then as linear relationship should be there. No significant outliers, independence of observation, and homoscedasticity. Once I I can confirm that all these assumptions are met, then only I'll apply regression. So now again you can go to your data. This is your data. इसको मैं बंद कर देती हूँ. Okay, this is my data. I'll go to analyze and then regression. Okay, then linear regression. A current visit time taken to reach mall. Let me see my questionnaire first, where I want to apply. For example, time spent at mall. This is ordinal. Let me take scale data. Okay. Scale data mein you have amount. This is a current time to reach mall and amount, a number of store visited. For example, for me, number of store visited will depend on amount. Like for me, number of store visited is a dependent variable, and it depends on amount spent on food items. Like how much amount I'll spend on food item will depend on how many stores I visited. So if this is my assumption, amount spent on food item and number of stores visited. Statistics may you can keep this. Durbin Watson you need to take. If it does not take, please take Durbin Watson statistics, because this is one of the assumption. And the value of Durbin Watson should be less than 2. If it is less than 2, then your assumption is met, and then you can go for this regression test. Plots may, if you want to draw histogram, then you can keep it like this. Continue. It's not required right now. Degree, this is also fine. Okay, so now you can just click on OK. It is significant. Durbin Watson is also less than 2. Okay, so what it is telling you, Durbin Watson statistics tells you about the independence of observations. Okay, so it is less than 2. So you can always say yes, your assumption is met. ANOVA will tell you whether your model is fit or not. So model is fit because again significance level is less than 0.05. Okay. So this is for model fitness. Now, these are the coefficients. This is a unstandardized beta coefficient. Significance level is mid, and number of store visited. There is a negative relationship between number of store visited and amount spent on food item. So